Okay, welcome back. This is our first Friday together. Serious. Hybrid learning every other Friday. We'd have thought of such a thing. Okay, so March 12th. Okay, we're getting ready for Pi Day on Monday, Tuesday. So I can use a calculator. I can remember this thing called the Pythagorean Theorem, a squared plus b squared equals c squared. I can solve for an x. We've got to be able to balance the equation and solve for x. I can use this thing called the square root button. And we got our puzzles. So let's just look at the calculator. Hopefully you're getting this downloaded, the Webbit, or if you have an Android, you got the Webbit, or you have your own. Okay? Now if you're just using a regular calculator, that's fine because they will have these two buttons. Square root, x squared. They're the opposites of each other. So 2 times 2, 2 times 2 is 4. Cool. 2 to the 2 power is 4. How do you undo a squared? They're right next to each other. Remember, all the buttons are next to each other. Plus, minus, multiply, divide. Square, square root. 10 to the x, logarithm, e to the x, natural log. Okay? So let's go second square root of 4 is 2. All right, enough of that. Moving on. Okay, what we wanted to do is devote these Fridays to a fun activity and algebra skills. All right? So the first thing we want to do today is just kind of talk about some triangles. All three angles less than 90 degrees. Quick, quick, quick. Come on, we know the answer to this. Vocabulary. Acute. Acute. And just for fun, if we said 60, 60, 60, remember what that's called? Equilateral. All right, equilateral. All right, one angle, 90 degrees, and we're going to live in this world for the next 5 weeks. 90 degrees. These are called right triangles, and just to be more specific, we're going to spend a lot of time on the 30, 60, 90 and the 45, 45, 45. So I'm actually going to write it up here. 45, 45, 90 and the 30, 60, 90 degree triangle. Okay, so if you look around the room, see what Mr. Miller's got posted up. We've got some posters on this, and we're going to spend a lot of time on this. Okay, bigger than 90, obtuse. Obtuse. Right? Big. Big. So, greater than 90, less than 180. Alright? Alright. Area of a square. Remember area of a square? Come on. The area of a square. Come on now. Dun, dun, dun. Length times width. Alright. So, area is length times width. And if this is a square, see, square, 6 times 6 is 36. But today is all about the calculator. So pull up a calculator. 6 times 6, we got a 36. 6 squared 36. And then how do you undo a squared? The square root button. All right. Area, 4, 4. Okay. Area, 4 to the 2 power, 4 times 4 equals 16. Okay. And again, we wanted you to practice using the calculator. Okay, especially if it's the online one, so you get used to using these buttons in your mouse. A lot of keystrokes. A lot of keystrokes here. 16. The square root of 16 is 4. All right. Find the length of each side. Now, if the area is 121 and the area is x times x equals 121, x to the 2 power is 121. Now, this is where it comes in handy. How do you undo a squared? How do you undo a squared? Okay, so do you know your perfect squares? Come on now. What is the square root of 121? All right, 11. 11 times 11. So we got an 11 and an 11. Cool. All right, now, balancing the equations, okay? Draw your little fence, draw your little fence, draw your little fence, okay? Balance the equation. All the numbers together, all the variables together. So each one of these, if we have a plus, we're going to subtract. We have a minus, we're going to add. Remember, you always do the opposite. Always do the opposite. A plus, we have a minus. Okay, now pause the video. Oops. Pause the video, and you do each of these. Remember, we're trying to undo the squared. Undo the squared. See you in a minute. Okay, we still have the x squared, we still have the equals, and this is going to be what? 65. We still got the squared, we still got the equals, and that's 100. We still have the squared, we still have the equals, and 144. Okay, now I want to take a moment to make sure that you realize the reason we did this is to balance the equation. Balance the equation. Balance the equation. We got rid of the numbers on one side, we got all the letters on the other. Now, for some of you, the new learning. To undo a squared, take the square root. To undo a squared, take the square root. To undo a squared, take the square root. X equals 12. X equals 10, x equals, let's grab a calculator. Let's grab a calculator here. Second, x squared, 65. 8 times 8, 8 times 8 is 64, so it's going to be 8 point something, right? Excellent. 8.06. 06? Yep, 062. Good enough. All right? All right. Now remember, this is a skill we have to have, so push yourself. Okay? All right, let's move on. Now, we just want to talk about lines. Okay? And every so often, we always come back to say, do you remember how to graph these? Okay? 2, 3. 2, 3. 2, -4. That's straight up and down. Distance. Distance. Let's just add it up. 1, 2, 3, 4, 5, 6, 7. -4, 0, -4, 3. 1, 2, 3. Okay. Now, this might seem like a strange activity, but every so often, and we haven't done any graphing together since we started hybrid. Okay, so we thought, hey, what the heck? Let's just throw in a quick worksheet here to make sure you remember graphing, because this really simplifies our life when we have a graph. 4, 3, 1, 2, 3, 4, 1, 2, 3. Okay, and I could be marking those more dark. -2, +3. 1, 2, 3, 4, 5, 6. All right. Okay. -1, -3, -5, -3. 1, 2, 3. What? 1, 2. You know what? I didn't draw that right, did I? Let's go here, here. Let's extend that a little bit. Yeah, extendo. Extendo. Now, some of you might be noticing that those are the same gap of 4. Those are the same gap of 6. Those are the same gap of 7. Those are the same gap of 3. Glad I did that. You see how many mistakes that Monty makes? What the heck? Alright, so practice and graphing, we need to have that skill all during math because we need visual representations of what we're talking about. Okay, now comes the hard part. Simplifying a square root. Okay, now we're all at different levels on this square root. Okay, now simplify is not the same as just solving it. Okay? Now if we grab a calculator and we were to go second square root 12 and we get an answer 3.46 square root of 72. Now just kind of sit back and watch the following here. Okay. Do you guys remember factor trees? Maybe? I'm going to take a minute and I'm going to build a factor tree on each of these. Okay? You guys remember back in middle school, what are the factors of 12? 2 times 6. What are the factors of 6? 2 times 2 times 3. Okay, now, you see how we have a 2 times 2? What happens if I write the square root of 2 times 2 times 3? That's the same as the square root of 12. Okay, well, the square root of 2 times 2 is 4, and the square root of 3. What's the square root of 4? 2. Good. Whenever you have a pair, okay, whenever we have a pair, one breaks out, one dies trying. 2 radical 3. Okay? This is a simpler version of this. Okay? So, as you go into Algebra 2, for those of you moving on, you're going to need this skill because we really like to be able to write the simplest version. Okay? The simplest version. And depending on the time, with hybrid learning, we may not have time to do this. Okay? Watch this one. Factor tree. 2 times 36. Oh, you guys know your perfect squares? 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. Perfect squares. I can rewrite this as the square root of 2 times the square root of 36. That's legal in math. I know the square root of 36. It's 6. The simplest version here is 6 radical 2. Okay? If you wouldn't have known that, we could have gone further. 2 times 2 times 18. 2 times 2 times 2 times 9. What's the square root of 9? What's the square root of 4? 4 times 2 times 9. Now, I know I'm losing some of you, but that's okay. Factor trees. When we're talking math, we just want to have fun with numbers, okay? It can get messy, but these are called like number skills. Do you like numbers? Just messing around with numbers. All right. Now, hopefully, everybody, when you see 100, ding, 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 5 times 100. Hey, let's continue this. 7 times 7 is 49. 8 times 8, 64. 9 times 9, 81. 10 times 10, 100. Our perfect squares. You see how when we're making a factor tree, we're looking for the perfect squares? And there it is. We know the square root of 100 is 10. Square root of 5, square root of 100, square root of 100 is 10. The simplest version is 10 radical 5. All right, so I wanted you to see that. I wanted you to participate with it, and I want you to just have some fun with numbers the next couple of weeks because we are going to spend some time just building factor trees. Cool? Another thing is, did you notice how I use the word square root, roots, and then when I was your age, we called them the radical. Okay? The radical. That symbol is called a radical. That symbol is called a square root. So much vocabulary in geometry. All right. Okay, that was the messy part. Let's go do a couple of practice problems. Next week, we're going to want to remember the Pythagorean Theorem, okay? And the calculator, okay? So Pythagoras said a squared plus b squared equals c squared. So we've got to locate our 90, locate our 90, locate our 90, locate our 90. All I want you to do is practice 3 squared plus 4 squared equals 5 squared. Is that a true statement? 3 times 3, 4 times 4, 5 times 5. 25 is 25. Yes. Okay, let's do another one. Actually, why don't you pause the video? I'm going to write them out, and you try each one. Okay? You try each one. We got our A, our B, and our C. Our A, our B, our C. Our A, our B, our C. A, B, C. Try each one. Okay, thanks for coming back. Did you try them? Some work, some don't they? This is what this exercise was supposed to do. It's supposed to refresh your memory on your perfect squares, because some of you probably remember them more than others. Okay? It was also to get you to learn to use the square root and the squared key. Okay? 106 does not equal 169. No. Oh my gosh. I remember Monty said this back in November. The 5, 12, 13 triangle. All right. And then you could see, if you've been doing these, that this one doesn't work. I have no idea what 16 times 16 is. 16 times 16, okay, and it will be 256. 169 is not equal to 256. No. Okay, so this has been 20 minutes. What I want to do is end this video so that you can come back. We've got a couple of quotes and a couple of puzzles for our first Friday activity. See you in a minute.